No, no, it's taking a movie. Good. Okay. Okie doke.
What day are we on,
12, yeah. Day 12. Not that many in the scheme of things.
I was just going to say, it doesn't seems like it should be a lot more.
It's
January?
Yeah. Yeah. We've had a few polls.
Yep.
Various people not being able to make it, including me. There we go.
Oh, did I tell you that I'm going to be out for surgery?
No. When's that?
That will be the 30th, which is a Friday this month. And I'll be gone for at least 2 weeks after that.
2 weeks.
So the 2 Mondays following, and that's if all goes well. If it doesn't go well, it'll be 6
It will go
weeks.
well.
Right.
It will go well.
So it's the difference between between laparoscopic or open.
Got it.
And they don't know
Until they get in.
So that's hopefully not.
Okay.
Okay.
Hey there. So today, unlike every other day where we have basically learned the syntax of C, today we're going to do something completely different and figure out how to put together a program that does something easy. And we're going to use everything we already know. So today, program design. And so we're going to go into the design process. We're going to talk about CSV files, which are what you can generate from your Excel file, make it into just simple text. And we're going to talk about another function that C provides called strtoke, which is string tokenized. We'll get there. And then we'll do some usual demos and class exercises. Okay, so review. Remember last time we did strings, and you declare them with the square bracket business and the number of characters that you want to be able to hold in that string. Usually one more than the number of characters so that you can hold that null. And instead of equals, we use string copy to make that string go into that variable. Equals doesn't work. And we needed to include all these functions, so we needed another include statement like this one here for include string.h instead of we're used to include standard io.h. And then the null marks the end of the string, so you always got to have room for it, and that makes it so you can have strings that are less than the number of characters that you set aside for holding. String length, another function. It returns the number of characters in that string. And when passing strings to functions, and when we declare that function, we do character star blah to tell C that we're passing a string instead of just a character. And instead of blah 10, we use the star so that we can have any number of characters to pass instead of just 10. So, today we're doing program design, and we're going to do a real-life programming example to kind of get into it. The basic idea is that someone defines what they want for some program to do. Usually it will be you, but sometimes it's somebody else. And usually in this specification, there's usually some input file or files, and how the information is stored in those files. Then there's output files, and how the information needs to be stored in those files. And then, what do you do in between? What is it you're actually doing to create that output file from the data in that input file? And that could be anything, right? So that's a very vague overview of what a program specification needs to be. And the programmer has to take this usually vague, very vague, statement and turn it into something that's very precise and works under a whole bunch of different circumstances with all kinds of different input files. So There's a lot of work involved in doing that. So here's the basic idea. You break the problem into a few smaller steps. You look at each of those steps, and you break each of those into smaller steps if you can. And you keep doing that. And you stop when you think you know how to code each of those steps, each of those pieces that you find in this never-ending iterative process. And then all that is English, right? All that, I didn't say it, but all that is English statements, phrases. You know, do this, do that. Now you start programming. Only when you've done this process here. Now you start programming, and you start with the smallest pieces, and usually the ones that you're least sure you know how to do. So you make sure you deal with those first. And then you slowly work your way up to the bigger and bigger pieces that you can find here. That way, each piece that you write is very, very simple. And you'll never get anything to work unless you keep it simple. So, let's go through this. Let's do it for real. So, here's an example. This is an example I got from Jen. And it's a nice, simple, straightforward, easy to understand by everybody, I think, kind of thing. So let's start with a CSV file that was generated from an Excel spreadsheet, and it was related to the copiers / printers. And so the file has the following columns of data: a username, a user ID, a copy machine number, number of black and white copies, number of black and white prints, number of color copies, number of color prints, and in that order. So that's the input. What do we want? We want an output CSV file that contains the following columns: the username, the user ID, and the cost in dollars. What they spent. Quarter, I think that's what it is. Fairly simple, straightforward, and something that can be easily automated with a computer program. So that's in, that's out. What do we do in between? The cost for black and white copies or prints is 5 cents. I'm making this up. While the cost for color is $1. So only non-zero costs are to be reported, and only user IDs that start with 0. So there's some other user IDs and report some other. So just the user IDs that begin with 0, and away we go. So we know enough for you to do this. Just to reassure you. This is not impossible.
As long as you, like, pretend you repeat the line.
Yeah,
Well,
that's right.
so now we will break this down step by step together. So file format. File format is a big deal. In order to be able to read the information out of these files, you need to understand the format. You need to be able to mess with the data in the file to turn it into what you need. So CSV is an acronym for comma separated values. Are you familiar with these? Have you seen them? And more or less, it's pretty simple stuff. You know, whatever's in each column, spews it, then it spews a comma, then it spews the next column, spews a comma, and you know, so that's all you get. So you get a bunch of values that are integers, real numbers, strings, and a bunch of commas. There's no spaces involved. It's exactly within those columns. So here's an example. And this is a real example. Been edited a lot because there were a lot more columns. Well, I simplified it a little bit to make it not too horrible for us today. But there's actually like 10 columns or something. So these are some of the columns from the file. And professor's name, numbers, and how many copies they made, stuff like that. And it's just got copies in between everything. And for some reason, all these things start with zeros. I don't know why. I don't know stuff, right? Got to deal with it. So there it is. There's an example CSV file. So that's the kind of thing we're going to be reading and then spewing out another version of it for use by whoever needs it, which I think you
I get a copy.
charge.
Once in a great while, I get her little corporate copy. Look at the copy. That right, that's good. Yep.
So, let's turn this into English steps. A bunch of steps in English. We try to make it somewhere between 5 and 10. For each time we do this, whatever it is we're trying to turn into steps, 5 to 10. Don't try to make it 20, don't try to make it 2. 2, that's fine. But you definitely don't want to make it too many steps. Because if it is, you probably should have made it fewer steps that were more vague. Try to make it just a few steps. So, for this, we're going to start with saying we're going to loop over every line in the input file.
What is loop over?
So, we've done while, and we've done fgets. Maybe you don't remember these. But it's a loop. It's a while loop that ends when we get to the end of the file, and every time through, it reads one line from the file. So that's what loop over every line in the input file means.
Okay.
And we've done it many times. Almost all of our programs are doing this.
Okay.
They're doing it from the terminal. They're reading something from the terminal, calculating something, going back, reading the next one. So we're constantly typing new lines. So loop over every line of the input file.
Yeah.
So read a line, calculate stuff related to that line. So we're being real vague here, but it's important to be vague. And then print, if it makes sense. And then keep looping till you're done, and then stop the program. So that's it in a nutshell, pretty much. So we have a loop to read every single line one at a time, calculate stuff based on just that one line, print junk related to that one line, if it makes sense, and then just do that over and over again. So it finally gets to the end of the input file, and we can quit. So, at the moment, we now need to decide which of these we know how to do in C and which we don't know how to do in C. So, loop over every line in the input file. We've done this before. We'll implement this in code later. We're done. Don't look at it again. Read a line. We've done this for simple stuff. But we haven't really done it for such complicated things as the C and D stuff. So we probably need to do some sub-steps to make this simple. So how about we read a complete line as a string, and then we read separate pieces of the string into the variables that we need. Those are what I would say are the two sub-steps of reading a line. So we don't know how to do this at the moment either. But these are the two obvious steps. We want to get that one line with all those different fields into variables. One variable per column kind of thing, right? So that's what this thing does. Right now we don't know how to do that. Alright, step 3, calculate stuff. Well, what do we need to calculate? So the total cost is the cost of how much a black and white thing is times the number of black and white plus the cost of color times the number of colors. Pretty simple stuff. Good enough, that's easy. Print if appropriate. Alright, what does appropriate mean? We only print if the cost is greater than 0 and the user ID string starts with a 0. We're just making it more like code here. So, okay, good. I'm done. Now we know how to do done. So that's step 2. Okay. Now, step 3, level 3. Read a complete line as a string. Okay, we've done that. So we're not going to do the code right now. Read separate pieces of the string into variables. Okay, this is the gut of what's complicated about this program. And so this is something that practically every program needs to do at one point or another. So string toke is something that the C compiler guys wrote to make this something that is easy. And we will now discuss string token. So you can see how easy it is to take one line from a CSV and turn it into a bunch of variables. So, before we get there, so this is our complete design. This is every step that we have to do in our program in order to make it work the way we think it should work. So we loop over every line. By reading a line, we first read the line into a string, and then we separate the pieces of that string into variables. We calculate cost. We only print if it satisfies this if statement, and we just keep doing that over and over and over again until we hit the end of file, and then we're done. So that is a English language sort of version of what this program needs to do. So now, let's go look at string token. String token is short for string tokenized, and it's in the include file for strings. The basic idea is that we tell it what delimiter or delimiters this file is using to separate stuff that we think is separated. So we've got comma and values. So the comma is what is separating things. In computer speak, it's a delimiter between these different values on one line in this file. So anywhere you see a comma, that is separating one value from another value. And so a token is merely a sequence of characters between these delimiters. So just to, I guess I think I have it. Yes. Okay, for example, this is our line with a bunch of commas, and tokens are these, each one of those values. Now, does that make sense? Now, that's pretty simple, reasonable. Wherever the commas are, you separate it, away you go. So you got a bunch of tokens. They call them tokens, beats the heck out of me. Computer speak.
The problem with this whole thing.
Yeah, lingo.
Supposed to make sense.
Lingo. But yeah, you can think of it as words, you know, whatever you're happy with thinking of it as.
You can't do this,
No string token. You get all the tokens. Now, there's a little bit more to string token than I've mentioned here. So I want you each to go to your browser and do a Google search on string token for me. And the first thing that comes up should be this C++.com thing. So click on him. And this is basically the online manual for C. And it is the place to go for examples for how to use each one of these things. So for now, we're not gonna read the top. We're gonna go all the way down to the examples. And so here's the example. They have a string and another variable for putting the result of string token in. It starts right here, PCH equals string token. String, in this case, they're using a whole bunch of delimiters. We'd only use comma. So PCH, first time through, PCH right here is going to get set to the first token in that string. So what is the first token? Anybody have any idea? I mean, this one's certainly more complicated than what we're trying to do, but as long as space, comma, period, and dash are all delimiters. So that's a delimiter, that's a delimiter, that's a delimiter. All these things are delimiters in between these things. So the first thing that's not a delimiter is this this word, this. So that's the first token that you get out of this thing. And then a sample and then string. So it's very much just like the words that are in this thing. Now if we just use commas, then this dash space this would have been our first token. Because then there's the first letter here, comma. So that's the basic idea. So here we are, we're setting PCH to string string, and then a bunch of delimiters here. Now PCH has been set to that first token. Then, to get all the rest, standard way of doing string token is going through this while loop, and as long as that thing is not empty, we do it again. PCH equals string token, blah. In this case, we use null, which we've never run into before. Null is just saying, don't use a new string, use the string that you remember. So string token is kind of strange. The first time you use it, it remembers the string you gave it. And in order for it to reuse the string that it remembers, you have to tell it null here, so that it just reuses that string over and over again. So every time you give it a string, it starts all from scratch again, it starts new. So this tells it, yeah, use what you remember as the previous string.
What's the while PCH exclamation?
Not equal.
What
That's not equal.
exclamation for?
So the exclamation is not.
Not, gotcha.
So yeah,
I forgot.
so not equal.
Okay.
So as long as PCH is not null, and
Okay.
null is basically empty, there's nothing there.
Okay.
So as long as string token keeps returning something back, then keep doing it. As soon as it returns nothing, we know that we've reached the end of the string,
Okay.
and we're done. So that's all that is. So you run it first with the string, and every other time you run it with null. And away you go. Every time it gives you the next token. And they're not doing much except printing the token. We're going to be putting it somewhere else. That's the basic idea. You run it once to get the first one, and you run it this way to get all the rest. And it returns null when it's done. But you kind of probably should know when it's done anyway. It's in our opinion. So that's the basic idea of how to do string token. And this is where you can go for examples. So hopefully that makes sense. I know it's kind of complicated, but it's basically just calling a function and having it return one word after the next until it's all done. That's all it is. So let's do this. So we've taken our code and we've written it in English. The hardest, lowest level step is this thing where we need to separate pieces of that string into the variable. So let's do that for one of the variables that we want.
Okay, wait.
Yeah.
No, just keep going.
So one of the variables that we need from these strings is the username. And it's the first one that we expect to see in our CSV file. So let's write a function to grab that from a single line from our file. So it needs to return a character string, which is the username. So we'll declare the function to return a char star. We'll give it a nice name, get username, so that we know what the heck it's doing. Then its sole parameter is the line that we just read in, whatever that huge line with all the comments and stuff. So this function takes that line, returns back to us a character string, which is the username. So we know it needs to be declared to look something like this. And we don't know what goes inside it yet. This is how I always start functions. What does it get as input? And what does it output? Then we try to work on the guts. So we know that string toke returns a character string of some unknown length. So we declare what it returns, like this, just like we have in all our functions, but we can also do this not inside functions. So we know that it's going to return something that's an unknown length. Just like up here, we declared this thing to be line, an unknown length. We declare toke here to be an unknown length string. Then we call string toke, given the line that we just read in, telling it to use comma as a delimiter, and we'll get back toke. In this case, that's the first token on the line, which is the username. So we have a vague idea that we need this and this in order to do that, but we're not sure exactly yet how to return it. So we've gone this far. We think this will do it. But I think there's probably a simpler way to do this, and that is just to return what string toke gives us. We don't need all this junk, because we're just going to return it anyway. So we'll just return what string toke provides to us as a character string. And that will get us the username, which is the first token in the line. Does that make sense? Even slightly.
Trying to follow, I don't worry about what
Right, so at the moment we haven't read in anything, right? We are writing a function. But we know that it's going to take this line that we read in somewhere as an input. So we just write it assuming we're going to read it in eventually. And we're not worried about doing that right now. We're just worried about it. As we told ourselves when we wrote all that English that we knew how to read lines. So we don't have to worry about writing that right now. We'll get to it. So this thing we weren't sure how to do. So this thing we're doing first. Because if we can't get this to work, we can't do anything else. So we always do the hardest part first. At least that's what I do. The hardest part first. So, okay, so this will return what string toke returns, which is a character string. And it's the first character string in this case. When we call it with a variable there instead of null. Okay, let's do this.
Okay. Hey, so I'm like back at square one doing my directory for the day and having a file because so if I just what do you call it? So I did that and then
CD to it.
That's why.
Yeah, you got to change your directory. And then Emacs, and let's call it test1.c and give it an and. We're just going to call it test1 because at the moment this is just to make sure we wrote the function right.
Okay.
So this isn't a program yet. It's just a test program. And so this is it. Here's our code that we want to test. And the rest of it, the main program here, is just to test. It's just to run this thing. It's just to test it. That's all it's for. So I just created a fake input string here with my name in it, just for the fun of it. And then I passed that to get username. And I want to see what it gives me as output. And if it gives me Leland, I'm happy. If not, I have to go figure out the fact that it's screwed up. Now, just like last time, there are bugs in this code. There's only one bug this time.
All right, so let's see if we can find it.
But hopefully this looks familiar. We're including standard I/O, we're including strings, we're declaring our function before we use it, then we come up with main, we got variables we got to declare, functions we got to call, then we define the function, and we're done. By the way, never name file test. The test is a Unix command for doing stuff. So never name a file. That's why this one's called test1. It's not called test.
If you delete your temp files, you'll delete your code.
Yeah. There's a few things like that.
Generally.
You never know which one's going to be laying around.
So I'll type in. So is it compiling?
I got that. I'm checking.
Go ahead, just compile. It'll yell at you. Dated by the string tokens, do it ourselves.
Right decision.
I decided to go with it.
Yeah, that was kind of crazy.
So how are we doing?
Well, the input string is undeclared.
Yes, definitely. And how is that possible? I thought we declared it right here.
What's missing is symbol.
Oh, what's missing what? Go ahead.
Well, it needs the same, it almost like it needs a star. But,
No, it doesn't need a star because we know how long it is. Down here we don't know how long it is. But up here we do.
That's all right.
oh,
I'll get it.
input string that doesn't have underscore.
Aha.
What?
Right?
Yes, exactly. And that's standard thing. I've got input string with an underscore here and here, but whoops, I forgot to put it here. I think that's the only bug.
You said one, so I only looked for one.
Actually, the first time I wrote this, it didn't work at all. Just so you know. After 35 years of doing this, first time I wrote this, it didn't work. It didn't compile. It was pathetic. And I'm not
Well,
going to
that
go
was
there.
that was a good revelation.
Yeah.
It's fine.
and it's unfortunately standard. Just so you know.
It's really good. Lots of moving parts and layers. And Jim Freudenberg, he's one of our guys, and he was talking to, he got interviewed from some radio show, and I listened to it, and he said, like, in a standard car today, there's 10 million lines of code. Now, in a fancy car,
10 million.
there's 100 million and more lines of code.
Oh
You know, and the whole thing is, like,
Oh
you get
my God.
engineers to write, because these cars have to do, they have to park for you, and, you know,
Yeah.
listen to your voice and say, play, whatever, you know. It just adds to the more codes, and I was like, 10 million lines.
Yeah.
It's
That's
even
crazy.
hard to wrap your head around,
That's crazy.
and that's one car.
Yeah.
So how many models and types of cars, like, I have an Impala, and there's the Impala LS, which obviously has more codes than what my car would have.
Go ahead.
It's just craziness.
It's all reusable. So if you make,
Sort of.
well, you make a program that could handle, let's say, the voice recognition thing. You have to
And
tweak it a
use
bit,
those
but you
cars.
could, yeah,
Sort of.
that you make.
Yeah. Sort of. And, you know, carburetor or whatever it is.
There's no carburetor.
Yeah, shows
Well,
my
and
age.
it's- yeah.
You know what it is.
I know,
Something that deals with the
What was
carburetor,
your-
I had a carburetor.
and it deals with all the
Input
carburetors.
string doesn't have an underscore and star copy.
I know, no carburetors. I learned cars a long time ago.
I drove a couple carburetor cars. I had to spray ether in the carburetor every time I started it, and then
yeah.
hop in and keep it running.
Was the
And
other
every
one?
stop
'Cause
sign,
I-
put it neutral and keep it running.
Because my error was on line 6. Oh yeah, input string, the underscore, but what was the other one?
There was only that one.
Oh, I got something with it. What was that?
Line 7, expected blah before get username. Ah, you're missing a comma. Alright, printf, you have what
Oh,
to
I see
print,
it right there.
and then the arguments for that print. Okay, so, have you run it? Does it work?
Yes, it says leaving.
It says Leland. Yeah. That's always a good thing, right?
Well.
I just don't know if I would never have been able to type that around
Awesome.
like it.
Well, we're getting there.
And I was looking for
I think-
opening and closing, and commas, and, you know, all those things that you're getting
Yeah.
used to. Should know.
Right. Right.
And as I'm
Right.
typing, I'm thinking, how,
How could
I'm
you
so
ever
glad
get
there's
this to work?
engineers who design these cars.
Yeah, no kidding.
Because I certainly just want to drive it and go.
That's
Oh,
I'm
yeah.
so glad there's people like our
Yeah.
faculty that do what you guys
Right,
do.
right.
Because,
And just like this,
you know, I'm so glad.
you just want it to work. You don't
Right.
care about what's inside,
Right.
which is why I
It's
write
just amazing
programs.
that,
Right.
I'm so
Right.
glad people like you do like
Right.
the program. People like me, we'd be riding our bikes to work. You know, there's a job for
You'd be
everybody.
walking barefoot.
That'd be okay.
It would just be,
Yeah.
I mean, there's a person for every job, but I'm glad that someone can do that kind of stuff because it's
Yeah.
amazing.
Yeah.
that
Yeah.
How we doing? Does it run?
Yeah.
people who
All
want to
right.
know that.
Yeah.
All right, so, as a reminder of what we've just done, we have made up our own test data for this thing so that we could make sure our program would work. And this is a standard thing you always do when you write programs. You make up test data. Try to make it normal, and you try to make it weird. We won't go into weird too much, but it's a standard thing that unless you've tested it on all kinds of stuff, which you've usually made up, you never know if it's really going to work in all cases. So, we have succeeded in testing one routine that we need to make this whole thing work. Now we need a bunch more, each one grabbing out a different piece of that string. So, go ahead and write one to return the user ID. It's a slight tweak on the program you just wrote. See if you can get that to work. And make sure it works by testing it. And if you have no clue, just ask. highly recommend calling it test 2, for example.
Okay.
That way, the old one is there to look at, just in case you need to. That's always important,
Oh,
because
absolutely.
it actually works.
This, like in accounting stuff, you just like, well, this was done before, what is it?
Yeah,
I just
exactly.
look at last month, I just look
Exactly.
at the last time you filed it.
Yeah,
Do
yeah.
that same thing.
Without a doubt. And that's actually why you write programs, so that whatever it was the last time, you just run it again. You don't even have to look at the details anymore. Yeah, that's what we used last time, just run it. Done. Hopefully. All too often things don't work out the way you hope, but especially but hopefully, small tweak to this program. All you want to do is grab this right here, 064. Or turn that into character string. That's all you want to do. So I highly recommend calling it get user ID instead of say get username.
I just like copying it.
So Karen, when you save that, you might want to save it as test2.c, not
Okay.
just test2,
All right.
because it won't be happy if it doesn't end in .c.
Yeah.
You can type in anything. I'm just.
You can
I'm assuming-
copy and paste instead of retyping all that.
Oh,
I highly recommend it.
yeah, before, especially since it was happy before.
Yeah. So just let's see. How do you copy and paste? Let me try it and see what happens.
It was.
Yeah. I just did literally copy and paste.
Well,
That's
test
okay.
two.
Yep.
I have no idea why it's not working. I didn't try that.
That's what I did.
You're right. That's what it's set up to do. You're right.
Okay.
And it wasn't even highlighted. I was dragging it, it wasn't even highlighted.
I don't think you can drag it.
You drag?
No, you have to control C and then put your cursor in the window and control V. This is Windows.
Yeah. Okay, so how are we doing?
Well, so I'm trying to figure out how it knows what the user ID is.
How does it know what the user ID is?
It wants to be a
You know.
policeman.
You know. Yeah.
Right.
It's the second token in the line, right?
Right.
Always.
Right. But,
And we wrote code that always gets us the first token.
and that's where I'm trying to look to see where it
So we
said
need-
that was the first token.
Yeah.
Before.
And string toke, when you call it with a variable there,
Yeah.
it gets you the first token.
Okay.
That's it. It gets you the first token. So when you give it null, it gets you the next, and the next, and the next every time you call it with null. So in order to get the second token,
Yeah.
you're going to have to call string toke would know.
On the last line.
Well, somewhere. I simplified things here in such a way that, it doesn't do anything except return.
Okay.
You may want to do something else before you return.
Okay.
I'm evil.
Mm-hmm.
How we do it on time?
Of 12:56.
We can do it. We can do it. We can do it. For homework, you can write all the rest. I know you always do your homework.
That's right.
Okay, null always has to be in capital letters, for whatever reason.
So I'm not taking notes, so that's obviously one problem.
No, yeah. No,
Ding,
you're not
ding,
saying
ding,
I did
ding.
anything right.
Undefined reference get close. So truly needs knowledge.
Yeah, you also need a function then get unity copy. Which you don't. You've got function definition up here, a declaration, and you got the definition down here of username.
Oh my gosh.
Case matters. And you've got a trailing E. That's good. One thing at a time. All right. So we are stuck in Emacs.
Oh.
We do an and in.
Oh,
So I would hit save and then kill it.
and then kill it there.
Kill it. And then it tries to do everything.
Oh.
So now you can try to compile.
I got Leland.
So you're back to Leland. That's good. So what do you need to
Pick
do?
black and white copies.
So what do you need to do to make that get you the second token instead of the first token? That is the whole thing about
Take
this.
Leland out of
Right?
here.
Where'd you get to?
No,
Oh,
you don't want to
one.
change
That's
this
it,
at all.
for
You want to
red
change
before-
this so that it gets you the
Oh.
second token instead of the first token. Because the second token is the user ID.
Right, so here's your service. Turn line
And
two.
No. Go back to your browser. Back to this guy. Remember when we did this? That gets you the first token, and these, each one of these inside the while loop gets you the next, and then the next, and then the next. So you have to do this in order to get the next token.
Right. So my error was odd one.
Yeah, because when you use while, it's expecting a logical expression inside parentheses. That has to be true for it to continue and false when it stops. So that's not what you're doing. I highly recommend not doing while. So, as you remember, with string toke, the first thing you have to do is call string toke with the string variable that you care about. So if you call string toke with line and comma, that will get you the first token in line.
Right.
And the next time you call it, that will get you the second token in the line.
Gotcha.
So that's what you care about.
Gotcha. Return the second.
So return the second. and ignore the first.
Gotcha.
Simple as that. So you're getting there. So the whole idea,
Okay, so you're touching
the whole,
That's right, go.
you always got to do that and.
Hit over here.
Yeah.
So the whole idea
Control C.
is that
Now say feature, put that down.
this
Feature, put that down.
gets you the
Okay,
first
so now
token
that's in the background.
Okay.
in line,
Okay.
and
Thank you.
this gets you. I can't type. This gets you. No, close. No. This gets you the second token.
Oops, just do it.
Yeah.
This gets you the second token in line, which is crazy
Yay!
because you don't give it lines. But
Yeah,
this is what you do to get the first one,
Too.
and this is what you get for the second one. And every time you call it next,
Now,
it'll get you the next
you could
token
easily extend it.
until
What would my
until it
third
gets you
line be
nothing.
to get the third
Yeah,
line?
exactly.
Oh,
That'll get you the third one. That'll get you the fourth one. That'll get you the fifth one. Just keep calling it,
cool.
Oh.
Cool.
and away you go. Now we're not
But
after
they-
those. All we want is the second one, so let's return it. Done. That gets you the second one. Now I wouldn't call it get VW copy. I'd call it get user ID, but you know, whatever you want to call it. So that should work.
Get user ID instead of like get
Yeah. This is,
username.
at the moment we're getting the user ID, aren't we?
Yeah.
Get user ID.
I thought we were getting voicemail.
No, that's next. You got ahead.
Woo-hoo, thank you.
First we want to get the user ID.
Oh, right. This,
Save
okay,
that.
Okay.
Try compiling, see if it works.
Yay.
And if you want, you can try to get the number of black and white copies as homework.
Okay. Not that I don't want to. See you guys.
See ya.
Hey, Karen. But it still
Did
gets
it run? Oh, yeah, whoops.
black and white copy. So this is where I put you.
Get user ID. Get user ID is the name of the function. And you're just calling that function. Yep. No, there's no underscore. I just made it one word. There you go. Almost. Got an extra character in there. Now, who cares? Every little detail. You got -0 instead of -0.
So that's kind of my
Yeah, because it's got a dot in the middle of it.
Typos are actually
It doesn't work that way.
the worst part of programming.
Yeah,
Typos,
and they never go away.
they never go away.
Yeah, as a matter of fact, as you get older, it gets worse.
You can't see so good.
And for some reason, your fingers don't quite do what you're thinking.
I've noticed that.
Yeah.
Ah.
All right, you got 064.
Oh boy. Okay.
Wasn't that easy?
Yes, because I had wonderful examples and people like.
So,
And
string
that's how
toke.
people program.
Yeah.
One look for examples and then.
Well, this I always
And that's
look for
what
examples. I'm
that's
like,
what this was all about. That showed
Yeah.
you the example of how to use string toke. And I
I
think
knew how to
that's
apply
an
it, that would have.
that's an important thing to see, that the examples are out there for you to
That's
take
good.
advantage of. That's part of what I want to teach you, because that's how everybody programs,
That's
so
how
that's
you
what
do
you
it.
should be taught. And so next time we will continue this.
Okay.
We will write everything and slowly build up
Get a little-
to the whole program.
Thing of what Jennifer could tell us
Yes,
what our copies are for the
exactly.
for the quarter.
She spends an hour on this every quarter, which doesn't sound like much time, but instead it could be
Yeah.
10 seconds.
Sure. Yeah, just let them do all the figuring and the editing.
That's what the program is all about.
That's good.